This video shows you how to map the supply structure for a medium using Visual Energy 4. But let's start with some basic information about metering points and the reasons for defining a supply structure. Just as with many other solutions, it is necessary to create metering points in order to facilitate the capturing and evaluating of data. These points represent specific measuring positions within a supply structure and contain information about the type of measuring device, for example. In principle, this would be sufficient to evaluate consumption values. But when you have to manage a large number of metering points in particular, the whole thing can quickly become quite a complicated affair. The result is inevitably an implausible evaluation. This is best explained by way of a short example. You measure the energy supply from your electricity supplier. It feeds a distribution with partly metered and unmetered outputs. Part of these outputs is not fed directly to the consumers, but in turn supplies distributions with outputs to consumers or, in some cases, to further distributions. In order to be able to work with the measured data, each measuring point must be provided with a unique name. This is then referred to as a metering point. This metering point list is the basis for evaluations in all energy data management systems. In this case, the actual supply structure fades slightly into the background, and quite often metering points, which are arranged one after the other in the structure, are added or allocated to a cost center when evaluating the often hundreds of measuring points. The result: their consumption rates are captured and evaluated twice. Fortunately, this is impossible with Visual Energy. The program uses the supply structure you defined to generate accounting grids independently. The sums of the in-feed and out-feed measurements as well as their differences are therefore generated for each distribution automatically. Output measurements to distributions are automatically used as the input measurements for the downstream accounting grid. Thanks to the unique OBIS code of the measurement values, the energy flow directions are also processed correctly, and even home power generation systems, clutch switches or regenerative drives are taken into account. Mapping of the supply network is actually quite simple. It is possible to create as many distributions as you like via a menu command. For instance, it requires just a few properties to specify the position in the overall view. You then add drawing elements to the distribution. The program contains an extensive library to meet the majority of requirements of the supported media. If this library proves insufficient, the user can define further icons and drawing objects. The sequence of the individual drawing elements can be altered at a later date. Visual Energy also creates further sheets automatically if a page is full. The drawing objects can be labeled with various properties and adapted to the particular conditions. A key setting is, in this instance, the selection of the correct type of connection. Depending on their respective drawing element, you can choose between energy supplier, customer generation and distribution for an input, and between distribution and consumer for an output. This means you inform the system how the measured values captured here are to be processed in the accounting grid. According to the selected drawing object, various components can be selected from a freely editable component database. The presentation is initially completed much faster and easier. During the second step, direct settings are, however, also derived from the component properties, for example for the fuse monitoring system SecureF. Only a logged-in user with system administrator rights is allowed to process the components. The user can then edit the component database in the system configuration and, for example, adapt properties or the sorting sequence. Another very important point in mapping the supply structure is the allocation of a metering point to the drawing object. This basically informs the system where a metering point is positioned in the supply structure and how it is to be processed. This occurs in the properties of the drawing object. Select from a list containing all the, as yet unallocated metering points for the current medium at the selected location. Visual Energy takes care of everything else. If live values are to be displayed at the drawing object, a data point can be selected in just a few clicks. Visual Energy also assumes another task that involves intricate configurations in other systems. With every online data point, the system automatically creates a link to the predefined device-specific views. At the click of a mouse, the user can therefore switch from the selected instantaneous value to other available live values. Another example shows that the installer does not have to deal with access to historical information from the selected metering point, such as load profile data or extreme values. Visual Energy automatically provides various evaluations in the form of diagrams and reports by selecting a drawing object with metering point allocation. The user can therefore analyze the temporal utilization, for example, via a single click. Let's turn to the supply structure. You have learned how simple it is to create distributions. I will now show you how easy it is to interconnect the individual distributions and how this results in the automatic formation of the supply network for medium. The connection of two distributions occur via their drawing objects. In the higher level distribution, you require a drawing object that has been configured as the output distribution. And in the lower level distribution, one that has been defined as the input distribution. Select the drawing element from either the output or input side. Under Properties, Visual Energy provides you with a list of all the as yet unconnected and appropriate drawing elements. Select the desired distribution and save the configuration. Visual Energy uses this simple definition of connections to generate the supply topology. But that's not all. If metering point allocation is defined in a connection on one side, it is also used automatically on the opposite side if no measurement is available there. This provides you with precise energy accounting with accounting grids up to distribution level. The system captures all the inflows and outflows and calculates the differences. Changes to the structure, for example, when relocating or extending machines and systems, usually lead to significant falls and implausible evaluations with conventional systems. Fortunately, this is not the case with Visual Energy. The calculations resulting from the structural change are redefined. Visual Energy provides you with numerous benefits. The evaluations always contain plausible consumer data, and your technical equipment is visualized with the current live data of the supply network.